At 10 minutes, there's a snapshot. You never want to bring that information in too early, because if you do, your derivatives will always equal 0, and you'll be like, everything's 0, Jeff. The universe is 0. Bleak. So don't do that shit. What's changing in this case? 3 is constant, right? The angle is changing, of course. Is that cool? As it goes further away, my angle gets smaller and smaller. You guys see that? Because first my angle is this. Holy shit! And then it goes, and then my angle gets smaller and smaller. Yes? Okay, so that needs a variable there. This distance is also changing, of course, as the plane's going 300 miles an hour. So that needs a variable there. So what the hell is that 300 mile an hour then? What does that relate to? Change in time of what? What up on that picture? What up on that picture? The change of what with respect to time? What's happening? I know it's in miles per hour. What variable up here? X, right? It's how much X is changing, right? When it flies overhead, what's X? What's X when it's overhead? What's X? You could do this. How long is this if it's overhead? 0. So isn't X changing? How quickly is X changing? That quickly, right? 300 miles an hour. Do you guys? Whenever you see that rate, you know it's going to equal d by dt something. So what's changing by 300 miles an hour? This distance is changing. So that's dx dt. So what do they tell me? Dx dt is 300. They also tell me one more thing, bless you, related to that. Bless you. What's the snapshot I'm going to take? How long is x at the time when I'm interested in what's going on? Say again? 10 miles. How do you get 10 miles? 10 minutes. At 10 minutes, how big is x? Yeah, 1/6 of 300, right? 10 minutes is 1/6 of an hour times 300. 50 miles. So x at a time when x is 50. So again, don't sit there and beat yourself. I didn't know how to do that. All right, you didn't know how to do that, but now you're starting to understand what to look for, the flexibility, how to be careful when you draw the picture, not to bring in information too early. So accept that you didn't have a freaking clue how to do this shit and go, well, let me see, how do I do this shit? All right, just start to develop, what is it that told me to do this? What do they ask me about? What's the symbol for what they ask me about? In English, what do they ask? Yes?
Is 0 just because it says it's passing overhead? Is that why x is 50 and not x plus 50?
Oh, yeah. It passes overhead. X, the way I've drawn the picture, x is the distance away from being overhead. Yeah. So how far has it gone away from being overhead? It's just 300 times the time. Yeah. In symbols, what do they ask me for? In English, what do they ask me for? How quickly is the angle changing? So what is that in symbols?
D delta? No.
Well, depending, I've given it a name already. D theta.
Okay.
That's what they're asking me for. I need to figure out what d theta dt is. Okay, so now the extra step for these problems, because of course this isn't pre-calculus anymore, this is calculus, is I need to set up the equation first and then take derivatives. So, is that angle in this triangle? Not yet. I can't use trig yet then. Where would that angle be in this triangle? Yeah, up here, right? Why? Anybody know the technical reason why these are, what's true about this and this? Parallel. So these would be alternate interior angles. I like it. Or however the hell way you get that theta in there. Because then you can use trig, right? What's the relationship I can make now between theta and x? Of course, it's going to use 3 too, but hopefully, right? I mean, what trig function takes over there? Tangent. Tangent relates the thing I know with the thing I don't know, right? What's tangent theta?
3 over x.
Yeah, 3 over x. Y side over the x side. Now, there's a few different ways to handle this, because what do I need to do next?
Find theta.
No.
Plug it in.
Plug what in? What I can't. These are dx dt, and I want d theta dt, but I don't have. I just have theta and x. So obviously, what's the next step? So I can use the information I know and want to know. I have to do what to this? Take it. And eventually, I'm going to have to figure out what theta is, but I don't want you to worry about that yet until I've taken the derivative, because not always will the variable stay alive. Now, can anybody, is this written really well? I'd much rather bring the x up, divide by tangent, because then this x equals 3 cotangent. Believe it or not, that's a much nicer thing, because what's the derivative of x with respect to t? What is the derivative of x with respect to t? It's the derivative of x with respect to t, guys. I love you guys. Right? Just dx dt. And how do you take the derivative of this side? What's the derivative of cotangent? Negative cosecant squared, so it'll be negative 3 cosecant squared theta times, what's the inside function? What's inside cotangent? Theta. So what do I need to multiply by? The derivative of the inside function, right? Which would be, yeah. So what's really, one level of this is, this better frickin' show up somewhere, because that's what they're asking me to figure out, right? So if you don't write this anywhere, you've done something wrong, because they want me to figure this out. But I don't want you to do every problem that way. But still, that's kind of like a nice check. If you didn't write that, you're like, oh, okay, how do I figure this out? It doesn't show up. So what do I want to know? This. What do I know? This. What do I still need to figure out? This is what Riam said earlier. What do I still need to figure out? What else is in that equation?
Delta.
Why do you keep saying delta?
Theta.
Theta. What's up with delta? What's going on? I got this I know. This is what they want me to figure out, so that I don't need a value for this yet. Theta is the only thing left that I need a value for. So how the hell do I figure out what theta is? At a time when what? What's happening at the time that I'm interested in? What do I know? I know x is 50, don't I? X is 50 at a time. That's the snapshot. So what's theta when x is 50? Can you figure that out? Or even better, let's see if you guys get this. Don't even get frickin' theta. That's going to be gross. Theta's going to be gross. Get cosecant theta. And you just got to square the bad boy. You guys see that? What's cosecant theta? What do I need to know to figure out cosecant theta? What's cosecant? What ratio, what sides? Hypotenuse to the y side. Because what's cosecant related to? Sine. And sine likes y. So what do I know the y side is 3. What do I need to know? Hypotenuse, right? I love you guys so much. If I just gave you this triangle, so this is how math works. At this point in the problem, all I'm trying to do is figure out what cosecant theta is. I have a triangle where everything's given to me. Right? I should be able to do that. So part of your brain has got to unlatch from the other earlier weird shit. Just focus on right now, what is it that I need? What I need has nothing to do with calculus. So what is this side?
50.0.
So it's the square root of 50 squared plus 3 squared, right? So square root of 2509. And then, yeah, whatever the shit that is. It'd be better just throw this whole thing in there, because what am I going to do with it immediately? What's this cosecant then? What's the cosecant of theta?
109.
No?
Oh, just that.
No?
3.
What's cosecant in general? Hypotenuse over y. Hypotenuse over 3. So square root of 2509 over 3. And what am I going to immediately do with that cosecant value? I'm going to, see, looking ahead tells you not to make things decimals, because I'm just going to square the square root away anyway. Don't immediately go to decimals. That's what kills me. Only do a decimal at the end of a problem, really. You guys love this shit, I can tell. So, there are a lot of layers to these problems. Pre-calculus should have gotten you ready for these multi-step kind of problems. So when I throw this stuff in, what do I know? I know dx dt is 300. I know cosecant squared is 2509 divided by 9. Is that cool? Just squaring that bad boy. And then I just got to figure out what d theta dt is, so I just have to get rid of that shit. Why does it make sense it's going to come out negative? As the plane flies away, my angle decreases, right? So that's why it makes sense. The answer is going to come out negative. There's all these checks and balances here. So now you just got to, I don't care about this part. Negative 100, negative 900, whatever negative 900 divided by 2509 is. Yeah, that was one problem. Yeah.
I feel like that problem incorporated everything I've ever learned about that.
Yes. That's the way you should feel about a lot of calculus. If you haven't felt that way yet, you haven't been doing things right. Whatever the hell that is, I don't care. I promise you this. Number 2 is a little bit easier. So, let's see. Try out 2A. What's nice about the volume formula, how many variables are involved already? 1. So there's not a lot of that tell me, ask me stuff here. I only have one variable to begin with. I should be able to just jump right into it. Oh, did I start you back up? Yes. Bless you. So let me just catch up a little bit with you guys. What is it they tell me? 2 things. In symbols, what do they tell me? Say it one more time. No. Careful. Use the already established variables. Yeah. Gas is escaping at a rate of 4 cubic centimeters, so it's got to relate to volume. Volume's already been given the letter V. So dv dt equals 4. And what else did they tell me? Just straight up, they tell me I'm interested when the, R is 24. Now be careful, that's a snapshot thing. You're not going to plug that in too early. So what do they ask me about in symbols?
Radius or dr?
Yeah, dr dt. They ask me how quickly the radius is shrinking. In symbols, that's dr dt. So I know my equation has to end up with a dv dt in it, and a dr dt in it, and maybe an r in it. Okay. What do you do from there? Yeah. So I've got the relationship already between volume and radius. If I take a derivative, I get a relationship between the rates of change of those things. Hence the title of the section, Related Rates. So if I take the derivative of both sides, what do I end up getting?
4 pi r squared.
I get this. Yeah, the 3 comes down, cancel, so I get 4 pi r squared. Sounds good so far. Missing something. Definitely missing something. I'm taking the derivative with respect to what? Not r. I'm taking the derivative with respect to what? Yeah, I'm taking the derivative with respect to t. If I was taking the derivative with respect to r, this would be done. But this is a function of t, so what do I have to multiply by? dr dt. That's the implicit step. I'm taking the derivative with respect to time. Anything that is a function of time needs the chain rule piece. And now I've got everything represented, right? I've got what they tell me in there. And then the r is 24, so I can put a 24 right there. And then this is what they're asking me for. And then that's just algebra from there. So this would be the 4's die. I can divide by 24 squared pi. And, whatever the hell small little thing that's going to be. It's going to be tiny. So it'll be something. What will the units be? This is awesome. Don't forget, this is the beautiful thing about this notation. Radius is in centimeters, and the time is in minutes. So if I just look at the symbols, it tells me what units to use. That's beautiful. And then whatever the hell number you get when you put this in your calculator, I don't care. That's the less interesting part. I already know the answer. There it is. Yay, you can rewrite it as a number if you want to. Nobody wants to tell me, so it's okay. All right. So we're going to finish this up. This last problem runs into the back. Oh my God. Yeah. But we're not going to be able to do section 3.7, so we'll have to do that for the next test. So this test will be through 3.6, comma 3.9. Can we get that? 2.8 through 3.6, comma 3.9. Those homework sections will be due. Yes.
So then his next class just review.
Yeah. I got to be the practice test, right? And so I'll give you the answer key next time, just like we did for the first test. Same idea. So next class, nothing new, just review. So try to do part A on this number 3. So it's going to be a lot like that trough problem, except now I've got this conical tank. So draw a little cone. It's not too bad. Draw a little oval and then just draw a triangle underneath it. Label it. Be a lot like that trough problem. You choose an arbitrary position for the water. Okay, so what's this here? This right here. $60 feet. I like the feet. That's constant, right? We're assuming that nobody's chopping parts of my little tank off or something. 60-foot tall tank, and of course, what's this? 20. All right, so those are unchanging. What's changing, of course, is the water. So what do I have to put here? For sure. I'm going to put H. It doesn't matter, really, but sort of does. Make it easier on yourself. And what's this going to be then? R. Okay. So the water could be anywhere in there. I just choose a place. Sort of like I just chose a place to put XY on that picture because it almost doesn't matter. Just choose a place. There. All right, great. Just want to have a little label, a little anchor for what's going on. Now, we've seen this idea before. What can I set up? You do this. Sure. Don't do that yet. What can I set up from this? No. Come on. Between the R, the H, the 20, the 60. Isn't this a relationship between R and H? R is to 20. your phone's like, escape, now. So R is to 20. So small is to big as H is to, because this is just triangles in here, right? It's just triangles, similar triangles. Oh shit, there they are again. They're going to show up. So that's useful. This is what they really tell me. This whole thing sets up a relationship between R and H, because what do they ask me for? Now you can set up the volume. What's the formula for the volume? Do you know what the formula for the volume of a cone is? This is so freaking awesome. So a cone is cut out of a cylinder. You guys see that? You chop it out of a cylinder. You end up, the cone ends up being 1/3, and you leave behind 2/3. Believe it or not, this is technically a pyramid. The definition of pyramid is all the corners go to a single point. So if I have a circle, the corners are every point on the circle, and they all go to a single point. So the formula for any pyramid is 1/3 the volume of the shape it was cut out of. So this would just be 1/3 pi r squared h. It's 1/3 of a cylinder. Don't freak out. I will give you the formulas. But you should know them. But it's okay. So you see how this is happening? We see this almost all the time. I have information I can help make this look better. Right? And the thing is, right now, I've gone a little further than I had to on this. Right? I don't know yet which letter to solve for, do I? The only thing this asked me to do was to do this, and I kind of went a little further. Part B starts to ask you, find an expression for the volume in terms, find an expression for the volume of the water tank. Okay, we got that. All right, we're there. 1/3 pi r squared h. Find a relationship between the radius and the height. We got that. It was r over 20 equals h over 60. Uh-oh. Is there somebody trying to come in? Maybe? We'll see. Maybe we'll have class end early. You're not supposed to come until like 9:30. All right. Part D, using what you found in Part C, rewrite this in terms of radius alone. So what do I want to solve this for? H. So of course if I multiply with 60 divide, I get h is 3r. Height's always 3 times the radius. So this would become 1/3 pi. Where am I at? Yeah, okay. R squared times h. This idea of tell me something, ask me something, use what they tell me in what they ask me. And now, just to simplify this a bit, the 3's cancel, the r's, so I just get pi r cubed. That's crazy. So now part E, what do they tell me in part E? Actually, what do they tell me at the very beginning? Let me come back. What do they tell me at the very beginning? Yes. So dv dt equals 48 pi. You guys see that? I did that on purpose so the pi's cancel later. Yeah, somehow I'm draining this exactly at 48 pi. Just, anything can happen on a piece of paper. And what else did they tell me? Radius is 16. And what do they ask me for in symbols? What do they ask me for? Yes, well, what rate is the radius change? So that's dr dt. So of course now that we've taken the time to develop this relationship between v and r, I can get a relationship between dv dt and dr dt. What do you get when you take the derivative of this guy? I'll do this side. Phew. What do you get on this side? 3 pi r squared. Yeah? Yes, dr dt. Derivative of the inside with respect to what I'm taking the derivative with respect to. And do I know everything I need to know? I know this, check. I know this, check. I don't know this, beautiful. I can solve for that. Right? So I know this is 48 pi. I know r is at a point when it's 16. And I can solve for dr dt. I don't remember making it this night. Oh, 16 squared. There it is. For a minute there, I was like, I don't remember this coming out to 1. Because 3 times 16 is 48. So 48 pi and 48 pi die, and I just have the other 16 left. So then I can divide by 16. I get dr dt equals 1/16. 1/16 what? Good. Look back. Feet per second. Kick ass. Now, real quick, this last question makes it sound like you got to start all over again and writing things in terms of h instead, but watch this. Don't I have a relationship between h and r? Therefore, I have a relationship between dh and dr. Kabam, right? H is 3r, so dh dt is thrice. Really, Jeff? Thrice? 3 times dr dt. So what's dh dt? It's just 3/16 feet per second. It's 3 times as quick as what the radius is changing by. Okay. Wow. Holy shite. So, real quick, on the practice test, I'm just going to have to load this test down with a lot of chain rule stuff because I'm going to have to kill. Now, this, you should actually be able to look at this and do it, but this is from that section 3.7. So, this is going to officially show up on the next test. But this is just, I mean, what do you think? If I gave you a position function, how would you get the velocity? What's the velocity? Yeah, you say take a derivative. How do you get the acceleration? Another derivative. Do you know what? So the first derivative of position is velocity. Right? Not the first rule of Flight Club. First derivative of position is velocity, because that's the rate of change of position is velocity. The second derivative of position is the acceleration. You guys ever heard of the third derivative? I always think back to my first car. It's called the jerk. So if you have an old car and you push on the gas and it goes, right? Then it makes sense why we called it the jerk, right? First derivative, velocity. Second derivative, acceleration. Third derivative is called the jerk, because that's that motion we get when the acceleration is changing a lot. That's the jerky motion, right? Anyway, sorry. Just so you can read certain shirts that have jokes about third derivatives, it's the jerk. Good movie, all right. So that's not going to be on this next test. Okay, so focus on everything else. There's a lot here, right? So don't say, wow, there's not much here. And yeah, there's a lot here. There's plenty for me to put on that test, so it's all good. Okay. Is everybody up to speed? What homeworks do, all that kind of stuff? I'm going to have to go on. Somebody's going to remind me to change the due dates on WebAssign for the other things. All right, and that's plenty. So I'm going to check about this room. Go to the other room next week. If it turns out I can have this room, I think I'm going to move us to this room. Nicer. Yeah, I should. What is it? I might know. There they are.
Thank you.
Oh.